Okay, so in this video here, we're going to take a look at how a valve works. And then we're going to look at a manifold, which is a series of valves together on a pipe, essentially. Okay, so this is an electrical diaphragm valve, which is usually what we use to control an irrigation system when we want to do automatic irrigation. Okay, so if you look at the valve here, there's an arrow going this way. That tells us that water is going to go in this side of the pipe and it's going to come out the other side there. So our water source is going to be over here. Water is going to be flowing through the valve according to the arrow drawn on the surface of it. Okay, so when our valve is turned off, it's going to look like this right now. So this is a valve with the face of it cut open so you can see into the valve. And when it's turned off, the diaphragm here is pushed down. Okay, so when the valve turns on, the diaphragm goes up like this. So that's the off position, and that's the on position there. Okay, so when the valve is at rest and it's turned off, this wire would be hooked up to an electrical source and no electricity is flowing through. Okay. So water is actually coming into here. It's going to go up through a tube and it's going to rest on top of the valve. Okay, so that keeps the valve closed. And then when the valve turns on, electricity is going to move the plunger in here and the diaphragm will go up. And then the water can go in and around that wall right there and out of the valve on the other side. Okay? So again, when there's no electricity, the valve is closed and water can't get out. When the valve opens, because electricity is flowing, water goes out the top of the valve here. Okay? Alright, so let's talk about the solenoid here, how that operates the valve. So when the controller tells the valve to open, an electrical signal goes down one wire and it comes back through the other wire. So as the flow of electricity is going in here, it goes through the solenoid, and inside the solenoid here is a little plunger with a spring on the end of it. Okay, like that. And when the electrical signal comes through the solenoid, it pulls the plunger up like that, and that button comes up. Okay, and when it does that, okay, so as the electrical signal goes down in there, the plunger pulls up, and then water is no longer flowing to the top of the valve. The plunger going open stops the flow of water to the top of the valve, and the valve moves to the on position. The diaphragm goes up. Okay? So some of the ways we can troubleshoot an irrigation system like this is, if our valve is not turning on and we think it's an electrical problem, we can come to the solenoid here and rotate it half of a turn, or excuse me, a quarter of a turn. So if you rotate it a quarter of a turn, the valve will turn on if electricity is not flowing to the valve. So that's a way to determine if our problem was with electricity flow. We turn this a quarter of a turn. If we turn it a quarter of a turn and the valve doesn't turn on, that means two things could be happening. The solenoid could be damaged. Lightning can damage the solenoid and then it has to be replaced. Or water is not flowing into the valve. The water source has been turned off. So the next step to troubleshoot that is to open this part of the valve on the top here. We can turn this open and it'll bleed the water off the top of the valve and open the valve if water's coming through here. So again, an overview of the troubleshooting. We can give this part of the valve a quarter turn here. And if it's an electrical issue, the valve will turn on. If it's a damaged solenoid, we should be able to turn the valve on with this screw here. Okay? By turning that open, we should be able to turn the valve on. Okay? If it's a water source issue, no water's flowing to the valve. When we try both of these, nothing will happen. And then we got to turn the water on, find where the pipe is broken or what valve prior to this is turned off, and turn on the flow of water. Okay? So that's the overview of diaphragm valve. Most irrigation systems are going to have multiple valves like that, and they're going to be set up in a manifold like this. So what's going to happen here is water is going to be coming to this manifold, and then all three of these valves are going to stop the flow of water at the same time. Okay? And then we're going to have these valves programmed to turn on at different times. So valve 1 will turn on, it'll run for 20 minutes, it'll turn off, then valve 2 will go on, it'll run for however long we want it to run, it'll go off, and then finally valve 3 will turn on, and then it'll go off when it's done. The idea here now is we can irrigate a much larger surface area with a limited source of water because we're running different areas at different times. Okay? You'll see 3 valves here. Again, the arrows point the direction of the water flow. If you put the valves on backwards, water will not flow through them. You also see that these 2 valves are like the first valve I showed you. They are AC current valves, meaning they're going to be wired up to a controller that runs off of the house's electricity. And then the valve on the far right is a DC or battery operated controller. And you see with this one, the electrical signal just comes from a battery in this. It goes out one way and back the other way. Okay? An important thing to note here is the DC controllers will have wires that are 2 different colors. AC valves, on the other hand, will be all black, or like this one, they are all red. The reason I emphasize that point is you cannot take a DC valve and hook it up to an AC controller. The valve and the controller has to match. This has to go to AC current, this valve here, and this valve has to go to a DC current. They're not compatible across each other. Okay, so that's all I have for valves and manifolds. We're going to talk about wiring up the valves to a control box and AC control box in a second here. Thanks, and I'll talk to you later.